Okay, let's take a look at the complex numbers portion of the radicals unit. So this will take us through the end of the February packet, number 53 through 60. Number 53, we need to simplify radical negative 300. So the way that I've shown you this is you want to take your negative 300, break it up to find your largest perfect square, which is 100. Then you want to basically take your negative 1, your radical negative 1, and then your radical 3, which is what's left over from 100, because 100 times 3 is 300. So the radical negative 1 is basically your I. Okay, so this becomes I. Radical 100 is 10. And radical 3 has to stay like that. So the answer is 10I radical 3. Now I'd like to share with you, if you completely forget how to do this on the Regents exam, you can actually do this on the calculator. So let's go ahead and take a look. So here we're going to go ahead and plug in square root of negative 300. All right, we get an error message. It's not a real answer. So what we're going to do is we're going to go to our mode, and instead of real numbers, we're going to change our number mode to A plus BI, or complex. All right, let's go back. Now let's try this again. And now we get a real decimal approximation. So radical negative 300 is 17.32 and some change. So let's go ahead and let's go through our answer choices. Now we know the answer is 10I radical 3. Let's plug in 10I radical 3. Enter, and there we go, an exact match. All right, let's go ahead and go through values or powers of I. So we have I to the first power is just I. Obviously, I squared is negative 1. I to the third power is negative I, and I to the fourth power is back to 1, right? Because 4 is divisible by 4 with no remainder, and that's why we get 1. So now that we have this, let's go ahead and plug in I to the 12th power. All right, now what does all this mean? We have basically scientific notation, 1 plus 2 times 10 to the negative 13th power I. This number is so small that it basically is 0. So 1 plus 0 is just 1. Now, if you're uncomfortable with that, you can actually go to your math, find number, and find option 3. This is I part. Choose that. I'm going to plug in the answer, the previous answer that we got, which is this, and it basically gives us what the answer really means, which is 1. Number 55, you want to evaluate I squared and I cubed first, multiply 2 times this, multiply 3 times this, and express your answer in A plus BI form. Number 56, you want to evaluate each one of these separately, right? Remember, you are adding these exponents, you're not multiplying. So you want to evaluate this, evaluate this, evaluate this. Then you want to solve this algebraically. Once you get your answer, subtract that on both sides, and n will be your n will be by itself, and it'll be equal to whatever the sum of all this is subtracted. Number 57, the conjugate of the complex expression, negative 5x plus 4i, is what? Now remember, the conjugate is simply changing the sign of the second term. So that's pretty easy. Number 58, The expression 3 minus 7i squared is equivalent to what? Remember to FOIL. I always want to emphasize when you see a binomial squared, just write it out twice. Okay, it takes an extra second to write it out twice, but you will not forget to FOIL. Number 59, more foiling. We need to FOIL this here and this over here. Okay, so just remember to FOIL very carefully, following all your rules and all your powers of I. And finally, number 60. So they give us x equals 3i, y equals 2i, and z equals m plus I. We're going to substitute in for this expression, x, y squared, z. This means 3i times 2i squared times m plus I. Remember, when you multiply, or when you take 2i to the second power, it's 2 squared times I squared. Don't forget to square the 2. Good luck.